Hi, my name is Taylor Torres, and today we're going to be talking about the fate of lactate. We have a lot to discuss, so let's get right into this. So to begin, we're going to be starting with the Cori cycle. So the Cori cycle is also known as the lactic acid cycle, and it refers to the metabolic pathway which lactate produced by anaerobic glycolysis in the muscle moves to the liver and is converted to glucose, which then returns to the muscle. So Cori cycle occurs when our oxygen levels are low. Our muscles undergo an anaerobic metabolism to obtain ATP for muscle contraction, and then our muscles convert pyruvate into lactate through the lactic acid fermentation, and then lactate's also used metabolically to produce itself in muscles and is taken up by the liver where glucogenesis occurs. And one of the things that I want us to place an emphasis on is that during the Cori cycle, it prevents lactic acidosis in the muscles, which is caused by a low pH in muscles due to high concentration. I'm going to explain a little bit more about the lactic acidosis later on in the PowerPoint and in the slides. But I just want you to remember that as we go throughout our presentation. So we see here on the right, this is just a diagram of the Cori cycle and how it occurs. On the next slide, I will be explaining the entire process and how it occurs. So like I said here, this is the Cori cycle process. So we start with glucose entering the muscle, and glucose is converted into pyruvate. That pyruvate is then converted into lactate. Lactate flows through the bloodstream, goes into the liver. That lactate is then converted into pyruvate. ATP is included into that, which then converts it back into glucose. Glucose goes into the bloodstream and then goes back into the muscle. And that process is continuously occurring throughout the body while we are having certain muscle contractions and completing certain activities. So what we're going to talk about next is exercise intensity and training adaptations that occur during exercise and how that affects the Cori cycle and the production of lactate. So at a steady rate of moderate physical activity, it allows the body to regenerate glucose needed for muscles to function and perform. So when our body, like I said, is at a steady rate of light to moderate physical activity, our body is able to go through that Cori cycle process of converting glucose into pyruvate into lactate, goes through the bloodstream, back into the liver, and then et cetera, et cetera. It's able to do that because we're at a low to moderate intensity and it's not needed at a faster rate. So when we get to a high intensity, strenuous physical activity, our body is not able to regenerate the glucose from lactate because it's needed at a quicker rate and our body is unable to do that. So like I said, talking about the lactic acidosis, we're going to discuss that a little bit right now. Lactic acidosis is one of the downfalls of the Cori system because it's the accumulation of excess lactic acid in the system. So when we have a decrease in pH level of the blood, which can damage tissue and induce vomiting, it is the body's defense to slow down rigorous activity. But this only occurs when, like I said, we have an excess amount of lactic acid in our body. So just those signs, like I said, such as inducing vomiting, abdominal cramps, hyperventilation, those are signs for the body to say slow down. We need to slow down what activity we're doing, and our body needs to try and recover and not damage itself. So the next thing we're going to be talking about is ABLA. ABLA is the onset of blood lactate accumulation, and when we think of ABLA, I want us to think of lactate threshold as well. ABLA and lactate threshold are used interchangeably, but each represents a different point for intensity of effort and blood lactate level. So ABLA is specific to a steady rate of physical activity of anaerobic metabolism that matches the energy requirements of active muscles. So during ABLA, we have little to no blood accumulation due to lactate production that equals the lactate disappearance. So for an example, when let's say we are doing a steady rate physical activity such as walking, our body is able to go through that Cori cycle process and produce the proper amount of glucose that we need to be able to contract our muscle and do the activity that we need. But on the other hand, when we have no accumulation of lactate production, we have a lactate disappearance. So we're using that lactate, and so we're not replacing it with anything else, and so lactate's going to disappear from our muscle. And that goes straight into lactate threshold. So our lactate threshold is the maximal intensity of our body that can maintain for an extended period of time with little or no increase in lactate in the blood. So here on our right, in this figure, we have the factors that relate to detecting the lactate threshold from gas exchange from pulmonary gas exchange, during physical activity of progressive intensities. So depending on our intensity will determine the lactate threshold and how quickly we need to go through this, or how quickly we reach this threshold, So our first step is we have an inadequate delivery of oxygen, which, like I said, is the beginning of the Cori cycle. Then we go to our anaerobic metabolism, which causes an increase of lactate. Then we go through buffering, which we're going to talk a little bit about in the next few slides. Then we go through minute ventilation, and lastly, the respiratory compensation of metabolic acidosis. So the main thing that I want us to remember from this slide is just the correlation between ABLA and the lactate threshold. Like I said, the correlation is that depending on the intensity will determine which concept will be applied. Next, we're going to talk about lactate and lactic acid. So lactate and lactic acid are interchangeable. Most people, when they're having a discussion with someone, they use lactate and lactic acid as the same thing. They are very similar. The only difference is that lactic acid has an extra hydrogen ion, which makes it an acid, and it donates that hydrogen ion and becomes lactate. So that's really the only difference. But other than that, they're very similar. Another myth that most people have is that when you are performing a high intensity exercise, your bodies are becoming fatigued, and we feel that burning sensation or tingling sensation in our muscle. Most people think that that's lactic acid or lactate, and that's not the case. What's happening is lactate is being used as our antidote to stop that burning sensation, and it's used to make sure that our body is not harming itself. And so we're going to go back up to lactate and talk about that lactate is produced in the body and is a response of aerobic exercise and fuels our muscles. It's produced to prevent the body from harming itself, and it delays fatigue and prevents injury. So like I said, when we feel that burning sensation in our muscles, it's not lactate or lactic acid that's causing that. Lactate is what's trying to prevent or be the antidote for our body from that burning sensation. So the last thing we're going to discuss is buffering. There are three types of buffering that we're going to talk about, but the main definition or thing that I want you to remember about buffering is that it's a chemical and physiologic mechanism to minimize changes in hydrogen concentration. So the first buffer is a chemical buffer. I want you to think of hyperventilation and how it releases hydrogen ions to maintain balance. a physiological buffer, and a renal buffer. The renal buffer is an excretion of hydrogen ions by the kidneys that prevents long-term defense and maintains the body's buffer reserve and alkaline reserve. So as we wrap things up, I just want you to remember the process of the Cori cycle, how it converts glucose into pyruvate into lactate, and depending on the intensity of the activity that we're doing will determine if we are able to have excess amount of lactate, or if we are going to have a disappearance of lactate, and how our body responds to that. That's all we're going to discuss for today. Thank you for everything. Here are my references, and have a great day.